Hello, I'm Stephen from TFAT Economics Tutoring, and today I'd like to give a presentation on the production function. The production possibility curve, or production possibility frontier, PPF, is a graphical representation of the different combinations of two finished goods, in this example good X and good Y. It's a convex shape. In Latin that means arched. You might see concave diagrams shaped that way. In other diagrams, concave is Latin for cave, but arch will help you remember. Think of arch on a cathedral in Europe. It'll help you know the shape of the diagram. So our assumptions are limited resources measured by price, the price of the finished goods. There's the concept, so limited resources, which is one of the assumptions of economics as a whole. The concept of scarcity of resources. Only two goods in this simple closed economy. The implications are there's a choice in this simple economy between two goods. In some of the old textbooks you might see a Robinson Crusoe figure stranded on an island with a choice between two goods with no opportunity for trade with anyone else. So our Robinson Crusoe figure has got a choice between two goods. Also, he has a opportunity cost, a trade-off between the two goods. He has to decide which bundle of goods of X and Y he wants on the production possibility frontier. Okay, those points are attainable given the level of resources. So points on this PPF. If there was a point inward of the PPF, that's inefficient because that person could shift out to the PPF and get more of the goods. So more of good X, more of good Y. Okay, but at a point out here past the PPF, that's unattainable given the level of resources. You would need more resources and a new PPF curve to get to that point. So that point is unattainable. Okay, I'll just flip the whiteboard over. So now we have to elaborate a bit. So that trade-off is measured graphically in this little triangle here, this little right-angled triangle. So the concept of opportunity cost is how much of good X do I have to give up to get more of good Y when you move along the PPF. Conversely, if I want more of good X, how much of good Y do I want? If I want more of good Y, greater, how much of good X do I have to give up? And that's represented by that little right-angled triangle there, the opportunity cost, the change in good Y and the change in good X. How much do I have to give up to get the other good? So now we're starting to look for an optimum allocation of goods. Which point do I choose along the PPF? Well, I have to introduce this price curve, and that's the ratio of the price of good X and the price of good Y. So that's a straight line. That's kind of like our budget, given our limited resources. We have to pay money for these goods and a price of the product price. Okay, so that straight line is our budget constraint. Now, we mentioned about the trade-off of goods, change in X and change of Y. That term is what's called the marginal rate of transformation, or marginal rate of product transformation. It's the trade-off between the good, MRT, marginal rate of transformation. MRT, and I could just put a little abbreviation here. So our optimum allocation of both good X and good Y is the intersection, the tangency of the PPF curve and the price curve. So that's our optimum, that point there, where MRT equals our budget constraint, our price schedule, the ratio of the two prices. MRT equals the ratio of the two price schedules. That could either be general equilibrium if you're considering the whole economy, all the people, or partial equilibrium if it's only part of the people and the population. So other slants of this opportunity cost concept I've seen in the literature, when you consider only one factor of production, say labour, so you're measuring the opportunity cost by the marginal productivity of labour with respect to workers in industry X over marginal productivity of labour with respect to workers in industry Y, equal to the wage rate of workers making X and the wage rate of workers making the Y good. But I don't want to elaborate too much on this. That was the concept I was lectured at when I went to university. I've also seen the opportunity cost measured as marginal cost of good X over marginal cost of good Y, which would also be equal to that price ratio. I'll just put X and Y here. Okay. So that's our optimum allocation of resources, where MRT equals the price ratio. Okay, that point there. I'll just bring another whiteboard forward. Now we've got to incorporate this into what's called welfare economics. Welfare economics, as I mentioned, could either be a general equilibrium, all the agents in the economy, or partial equilibrium, part of them. So we'll introduce consumers now, and indifference curves, which is down here. Just separate that from PPF. So I won't go into indifference curves too much because I could include that in an overall presentation of welfare economics, but consumers have what's called an indifference curve. It's a choice between the two goods, good X and good Y, based on the concept of utility. Utility is where they get satisfaction from the goods. Okay, so if you go to McDonald's today and buy a Big Mac or a Quarter Pounder, you get utility from the hamburger. But if you have 2 or 3 Big Macs, that's too much, and your utility starts diminishing, dropping. And consumers are faced with a budget constraint as well, also a price ratio, and the tendency of the indifference curve, the trade-off of the utility of the two goods, intersects the price ratio schedule. Okay, good X, good Y as well, on the respective axes. So their choice of goods along that indifference curve is just their personal preference for the two goods. Some people might like more of good X, some might like more of good Y, but they're all constrained by a budget constraint and the tangency with the indifference curve. So in the context of welfare economics, I will just say that budget constraint can also shift in and out according to the income effect, more income, less income, and the price of goods can change as well. I won't draw a diagram, but another budget constraint with a different price of good X might be here up to there, and good Y price hasn't changed. That's the substitution effect. Similarly, the price of good Y could change, and the price of good X stays the same, and there'd be a movement here with the same price for good X. That's the substitution effects. Income effects is more income, less income. So you've got, with consumers, you've got a concept called marginal rate of substitution, where it's a ratio between marginal utility of good X over marginal utility of good Y. And then before, sorry, I was going to get to something, I'll get to it now. So we've got a partial equilibrium. If we draw an indifference curve for the consumers here in the against the PPF and also the price ratio, so we're introducing consumers with a utility curve in the PPF. That's PPF here, and that's indifference curve. Remember that indifference curve is MUX over MUY. So the partial equilibrium is a tangency of both the PPF and the indifference curve, and also, of course, your budget constraint, the ratio of prices. So in welfare economics, marginal rate of substitution equals marginal rate of transformation. Remember that marginal rate of transformation is the trade-off between the two finished goods. Marginal rate of substitution is a trade-off with consumers' utility. Those two are equal and equal to the price ratio, but even though they're equal, these are different concepts. So don't be confused between the two. Okay, so I just wanted to introduce this. I'll probably give an additional presentation on welfare economics to incorporate isoquant, which is a production concept, but that's another presentation. So I'm Stephen from TFAT Economics and Financial Accounting Tutoring in Sydney. Thanks so much for watching the presentation, and I hope you found this helpful. Bye.